I'm going to talk about the 622 design circular queue. The question is design your implementations of the, this is circular queue. The circular queue is the linear data structure in which the operations are performed based in first in, first out principle, and the last position is connected back to the first position to make a circle. So it also called a ring buffer. One of the benefit of the circular queue is that we can make use of the space in front of the queue. In a normal queue, once the queue becomes full, we cannot insert the next element even if there is a space in front of the queue. But using the circular queue, we can use the space to store new values. So implement the myCirclesQueue class, right? So initialize the object with the size of the queue to be k. And this function's front, gather the front item from the queue, and if the queue is empty, return -1. Okay, so this is the get the last item from the queue. If the queue is empty, return -1. Insert an element into the circular queue, return the true if the operation is successfully. Deletes, right? The queue it deletes from the circular, return true if the operation is successfully. Okay, so insert, check is empty for, okay, so I will use like double link clicks to solve this problem. This is called like a head, right? This is the tail to handle the, this is come first in, and this is in, and this is out. Let's see. Node, I need the int value. Node priv is the node nest constructor. Okay. So for the global, I need the in the size, in the capacity, and the list node head, list node tail. What else? It's okay now. In the size, start from the 0, and in the this capacity is equal to the k head equal to the new is the node -1, and this tail equal to the new is the node -1 here, and connect it together. Tail priv is equal to head. Okay, so I will check for this empty first. If the size equal to 0, so which means empty, return true. If not, return false. Whether is full. So if the size equal to capacity, then we return true. Return false. Okay, so yeah, this is the very basic one. Now for the front end, front is actually is this way, right? So first thing is where close to the tail. So if the size, if it's empty, return false, return -1. If not, return the tail previous value. Okay, so for the enqueue or dequeue first. Dequeue is if it's empty, we return false. If not empty, so we can, which means there's values inside, so we can remove it. List node last equal to the tail the previous. Now we need to remove the last one, so which means the last previous need to connect it to the tail, and tail previous need to connect to the last prev. Last prev. Last previous the nest. Nest should be equal to the tail. And tail the previous is equal to the last previous. Yeah, okay. So, and also this one size minus return true. And for the enqueued, so we need to check is 4, whether it's 4. If 4, return the false. Otherwise, which means we can add it, return true, and size ++, and the list node is equal to the new node, right? Okay, new node add in the head, new node prev equal to the head, new node nest equal to the head nest. Okay, now connected them and break it. So head nest prev is equal to the new node, and head nest is equal to the new node. Let's see. This one. Okay. So if it's empty, return -1. If not, return the head nest. And for the time complexity to the average is 01. This is 01. And space, I didn't create extra space, so it's also 01. Yeah, thank you.